So I'll take questions right throughout the whole thing. So if you have a question at any point, just let me know. I'll answer. And then I'll try and have some time at the end for questions. Really, what I'm here today to tell you is just the story of, so I started at SourceForge 2.5 years ago, almost exactly. And when I started at SourceForge, everything on SourceForge was written in PHP, except for there was one small Python service called RTStats, and it was kind of a disaster. And so people did not have an extraordinarily high view of Python. It was written by a guy. He wrote it all sort of like in a cave by himself for 6 months, and then like they released it to production, and then he quit. It was awesome. And it works, but it was hard to maintain, and nobody understood it, and it uses Twisted and does a bunch of crazy stuff to be real time, and it was not well understood by our developers, and it had been a problem. But everything had been written in PHP. Originally, SourceForge was written in 1999. Python was not as well suited to web development in '99 as it is today. And PHP was a natural option. It was sort of written by this small group of people on the side, and it was just a project to prove that you could serve as many bits from Linux as you could from Solaris or some other operating system. And the company was a Linux hardware company at the time, and so they were just proving that Linux hardware could do all the fancy stuff that you needed it to do. Fast forward 10 years, everything is kind of atrophied a little bit in SourceForge. It's 10 years old. People were having trouble getting new features done. There was frustration with how things were going. And they said, oh, let's try a new modern web framework, and let's hire some people and see if we can do something different. And what they decided to build was this website called Phosphorus. And this was a tiny little experiment. They were going to have 2 developers work on this project for 2 months and see how it went. And it was just free software catalog, so free and open source software for us. And that was the site. And it just was a way to browse free software and find stuff that you might want. The first thing that they said was, let's choose a language in which to write it. Well, actually, they didn't. They said, the guy who was managing this, Nate, said to one of our developers, Paul, so you have 2 options, Django and Rails. And Paul liked Python, so he chose Django. And then they hired me, because if you're starting a Django project, the first thing you should do is hire the BDFL of TurboGears. Yeah. So they hired me. I worked on a Django project for 2 months. It was a good project. It was successful. In 2 months, we released it. People liked it. They showed it to the board. The board liked it. It got some traffic. Not a lot of traffic, but it was easy to find software. People used it, and it was pretty successful in convincing people inside the org that you could get things done relatively quickly if you used a modern tool set that had, like we used Django, OpenID, we used a bunch of reusable Django apps and got things done very, very fast, and they were impressed with that. So what did we like about this? It had CouchDB as a schemaless database backend. That worked really well for storing project data. We had Django apps like OpenID and Django Auth. Django had really good documentation. The other guy that they hired had never actually programmed Python before professionally, so he was coming up to speed, and the documentation in Django was great, and he was able to be productive that entire first 2 months. He was getting stuff done. There was no real learning curve. What we didn't like about it is that we were using CouchDB, and it wasn't quite fast enough for our needs, and to get it to be what we wanted it to be, we were going to have to replicate and do a bunch of work. We also didn't completely trust CouchDB to store all of our data, so we wrote our own index doc store in MySQL so that the data was in both places, and then we had code that synchronized the data all the time. That was a bad idea. Turns out Couch was trustworthy and we shouldn't have done that work. We didn't like Django templates at all, and we used Jinja. And this was 2.5 years ago. And 2.5 years ago, that was a mistake. Nowadays, it's probably not the mistake that it was then. But every week, we ran into something where we're like, oh, but we don't use Django templates, so this thing won't work at all. And then we'd have to monkey patch Django to make something work. Like we couldn't use RSS feeds because we weren't using Django templates. And we couldn't use, and it went on. And that's not true today, but it was true then. And Django, by default, was generating an awful lot of queries. And so we had to actually start monitoring the number of queries that we had per page and try and bring that down because it was getting out of control. So because this project was successful, they immediately took all resources off it and abandoned it. Awesome management decision. But they actually, I mean, on some level it made sense. They said, this thing gets, few thousand page views a day, maybe 10. And then we have this other thing, SourceForge, that gets, millions of page views a day and is way crappier. If you guys can fix that, in 2 months, make that thing better, create this thing from scratch. Can you make SourceForge better? Oh, and this time we're going to give you 6 whole weeks. So in particular, they wanted, this is the front page. We had to redo the front page, and they wanted to improve some usability. So this time, we got to choose again. What stack do we want to use? Do we want to just take the same stuff and use it again, or use something different? We were pushing the envelope just a tiny bit on Couch performance, on Phosphorus, and we didn't want to do that again because it was going to be a hard work to get. I mean, we had 2 orders of magnitude at least more traffic, so we didn't want to. So we were like, maybe Couch is not the right choice. But then we were like, oh, there was this thing called, I can't even remember what it was called, but it was a twisted front end that you could have multiple Couch servers on the back end, and it would, what was that? Something like that. And so we tried that and tested that, and we tried MongoDB, and we tried Cassandra, and we tried several other options. We tried Postgres and MySQL. It was currently all served out of Postgres, so we knew that would work. But we wanted replication. We wanted to be able to have each server be self-consistent or self-contained, so that if 8 of our front-end servers went down and 1 was still up, you would still be able to respond to traffic. Now we all know Python, meaning me and Dave. We all had used a document database, and we really liked it. It worked really well for our problem domain, which is you have a project record, you want to display a page about that project that has a whole bunch of data about it, but it's all basically the same data every time. And we knew the problem domain a lot better, but we only had 6 weeks. And we had to be able to handle more than 10 times the traffic. Not just more than 10 times the traffic that Phosphorus had, but more than 10 times the traffic at which Phosphorus would consistently fall over. So we knew we were going to have some scalability issues. We get a lot of download page views on SourceForge, and our project was just to fix the download page, the file browse page, and the sort of the consumer flow, the project summary page. And we're also, one of the constraints, which was a pretty good constraint to have, I think, was that we were only allowed to talk to the public APIs of SourceForge. We were not allowed to talk to the database directly and get the data that we needed. We needed to grab project data out of the public API and shove it somewhere and then display pages. It was partly to prove that we had public APIs and you could use them, because they were mostly broken in much of SourceForge's life. So we did a bunch of testing of various libraries. I just mentioned that it was more than 90% of all SourceForge's traffic goes to those 4 pages. And then if you include the front page, it's like 93%. And then our next goal was going to be search browse pages, and that would take you up to like 96 or 97% of all SourceForge traffic would be served from Python with very little Python code, but serving most of SourceForge's traffic. The big goals for it were to have bad slide layout, were to improve the usability of the page, to improve the performance of the page, and to have a system that was much more reliable. We were having some downtime issues. The big usability issue was we wanted to have this big green button that figured out what operating system you were on and let you download a file, because that didn't exist on SourceForge at the time. There's just like a browse files, and then you'd get to a page that had a list of all the releases that had ever happened, and then you had to figure out which one you wanted. So we needed to do a little bit of work to figure out what platform you were on from your user agent string. And then we had to do some other work to figure out what, because most projects did not tell us what the recommended download was. It was in the API and in SourceForge you could do that, but most projects had not done it. So we had to look and go, oh, it's 3.0 beta 4. Oh, that's better than 3.0 beta 3, but not as good as 3.0. So we had to figure that stuff out. And actually so for cheating, in the original version of figuring out what platform you were on, we had code like if Windows in user agent string dot lower. And then we stole the code to figure out what is the highest version from setup tools. So we just imported setup tools and used their little hoobajoo. Because it's crazy, and I did not want to figure that logic out again. And we only had 6 weeks. But that's sort of the beauty of Python, right? Like, I looked around and I'm like, hey, somebody has done this. And setup tools did it, and so we didn't have to write that code anymore. We did have some advantages, and again, my slides are being funky. Consistency wasn't critical. If someone did a release and some users were on one server and they saw the release in 4 seconds, and some users on a different server saw the release and it took 10 seconds for it to get to them, like that wasn't going to be a big deal. For a database perspective, that gave us a lot of options. We really wanted replication. We really wanted, when we launched, we wanted an architecture like this where each of the directory server, the front-end directory servers, had a local replica of the database because it wasn't that big. And that way, as long as one of the servers was up, we were able to serve traffic. When we went through and did all of our performance comparison of various databases, we chose MongoDB. It was a little scary because people were like, oh, it was pre 1.0. It was very, very new. It was incredibly fast. We were getting over 10,000 project reads per second in tests with project data on my laptop. And 10,000 reads per second was more than enough to handle all of SourceForge traffic off of my laptop, which was pretty good. At least that's what we thought when we did the testing on my laptop. We didn't have production data, and I'll get to that story in a second. Another thing that we used, all of our administrators loved them some Apache, and they knew Apache, so I just said, here's ModWizGi. It will work. It's an Apache module. We're going to tune it. It's going to be fine. And that worked out as a deployment strategy for us very, very easily because it was something our system administrators just knew. So we had 6 weeks. Oh, they said, oh, hire 2 people to work on this too. So during that 6 weeks, we were hiring 2 people and getting this project done. And because it was Python, that was actually not a problem. We did not work crazy hours and do insane things until the very last minute. And that was because they decided to change the entire theme and look and feel of SourceForge 2 days before we launched it. So we had a mad rush to get a UI that worked. But that had nothing to do with Python and just to do with bad design. But we launched 2 years ago at EuroPython. And so this was bad timing, but I was coming to EuroPython to do a talk on TurboGears. And so I flew out, I landed, and we launched. And I'm on the phone, and then I'm on my laptop. And the launch, we didn't have, these are lessons learned. We did not have any load testing system. And we were not allowed to load test on production hardware, even though we had completely separate production hardware that was on a separate set of connections and didn't touch any of the other servers or back end. It was all touching, like the servers hit Mongo. Mongo was a new thing. I was like, let's load test on this before we launch, just to make sure it's all good. And they were very, very worried that we would somehow take down the site by load testing the site before we launched it. So our load test was we just pointed all the traffic from SourceForge at it and saw what happened. Meanwhile, I'm on a different continent and I'm trying to figure this out. And we launched it, and on my laptop, it was really fast, even with all of the traffic for SourceForge. But on the live servers, it was a little slow. It wasn't dying, but it was like 8 seconds a page. It was bad. So all the front-end servers, we had 4. They were just sitting there. Hardly any CPU, nothing happening, like no load, no disk I/O. We're like, what's going on here? Then we look at that point, we just had one central Mongo server. And we looked at that Mongo server. It had CPU load was like 5%. It had no disk I/O. We're like, why is everything slow? And then it turned out that we had a gigabit network card in our Mongo server, and we were saturating the gigabit network with project traffic because we had decided to put a list of every release for a project in the project record. For a few projects, like JBoss would be a very good example. There are thousands upon thousands of releases over their 8-year history of tons of little tiny components. And so those project records were very large, maybe 4 megs. And we were grabbing them from the database every time we displayed a page. So we're grabbing 4 megs of data out of the database to display like a 130K page. So that was not working out well. So we're like, oh, we're going to move the releases out. But in the short term, our NetOps people bonded the 2 gigabit networks, and we had a 2 gigabit connection between the front end and the front end servers and Mongo. And then we just saturated that immediately. And things got faster, but it was saturated, and that was the bottleneck. And we fixed, then like an hour or 2 later, we deployed a fix that didn't do the, well, we added caching first. That was our fix. And when we added caching, things got really slow. And we're like, why does memcache slower than Mongo? Anybody know why memcache is slower than Mongo? Because we're using Pickle. And Pickle is way slow when you have 4 meg objects. So when we were serializing and deserializing, then we're also getting like CPU bound processes and CPU bound processes. There's the global interpreter lock. Even though we had lots of threads answering these, we were locking up. So caching into memcache was bad. So we just started caching into local memory, and that worked better for just a few projects, and that eliminated it. Then we stopped caching finally now, and just removed the offending data that we weren't using at all from those records, and everything got fast. But it took a while to update all the records to remove that data and put it in a separate collection. So that project, in spite of that chaos, the EuroPython week, was deemed a success. So they said, do more. And now we got to hire a couple more people, and we got set to replace all of the tools on SourceForge. And they wanted this time for it to be a platform. There was a big push from a manager who used to work at Microsoft. He's like, everything is platform. Platform is how you win. So he's like, build the platform, and then you can build some tools. And I was like, let's build some tools and extract a platform. And then we built a platform, and then we had to fix it when we made tools. Because, that's what always happens. So we built this platform called Allura. And the Allura had a bunch of different, this is the Allura project, by the way, tickets for it. So we now use SourceForge Ticket Tracker to track our own bugs and our own development processes. And it has some built-in things, like it has Solr indexing. It has a MongoDB document store. So a ticket, you can just say, index these fields, and then they'll be searchable via Solr. We built a ticket tracker, a wiki, file release system, Git, Mercurial, Subversion support, a discussion tracker, and a project administration control panel. So we built all of these things so that you had a bunch of tools that were plugins. So installing a new, or creating a new tool for Allura, a new tracker or discussion tool or something, is there's an application class that you have to write and use a setup tools entry point. And then that tool will just show up in this menu of things that you could install. So we have, as part of the platform, we have all of this stuff where we have Apache and mod WSGI still. We have an SMTP server for mail coming in and out. RabbitMQ is now optional. You can, the queue goes into Mongo as well as Rabbit. And RabbitMQ just makes sure that people get the message instantly. If you're willing to just poll Mongo occasionally, you can get the queue to work without RabbitMQ, because people have had RabbitMQ install problems. We have this reactor idea that we stole. So we liberally stole from the Python world. We stole this idea of reactors from Roundup bug ticket tracker, and then we index things into Solr. We put things in Mongo. We have OpenSSH, and we have a Fuse file system, which we wrote actually in Python. And all that does is permission lookup on top of a loopback file system, so that Git, Mercurial, Subversion permissions can be controlled from Python without modifying the Git, Mercurial, or Subversion binary. So we're using stock version control systems, but can give you fine-grained permission control for access to those things. So we had 6 months to do this project. It turned out to work pretty well. And so as we're about 2 months into this process, someone at SourceForge decided that the official language of SourceForge is now Python. And that we've done a good enough job that they proved that unless you have a darn good reason, everything that gets written from now on should be in Python. And so now we had to teach all of our PHP developers Python. That was easy. Turns out Python is great. And it all worked out. And in the end, Python just sort of won. And now the people who came in and did the original Python stuff are in many ways running development these days and have led us in a new direction. And we open source the Allura platform that I mentioned there and all of the tools that we use on SourceForge. We open sourced all of those this spring. So SourceForge is moving a completely new direction and I think has a chance to compete again. And it's because of Python. If we didn't have Python, we could not have done that. SourceForge was on I think my manager referred to it as a slow death spiral. It was just sort of, or circling the drain. That is a more recent metaphor that we keep talking about. Well, we used to be circling the drain, but maybe not anymore. And we've had more projects coming to SourceForge. We've had more traffic. SourceForge has been, I think, turned a corner since we started using Python. So you can say we have better management now than we did then. That's certainly true. You can say a lot of things, but I think Python is clearly one of the reasons that we've been able to turn a corner. So that's all I had, and then questions.
Are there any questions? Yep.
In the first project, you mentioned using Django, and then for the big one, source for rewrite, you didn't actually mention what you use for the front end.
So the second project, we used TurboGears, but we used a heavily modified version of TurboGears. So we didn't use SQL Alchemy. We just used MongoDB. So we tore out all of the parts of TurboGears that were SQL Alchemy specific. The transaction manager, we tore out a few things. And we chose TurboGears over Django, particularly because it was easy enough to tear those pieces out and get just what we wanted. And we had me and another guy who was a TurboGears core developer was hired right at that same time. And so we knew everything back to forward. And we were a little worried that there were going to be problems in the framework that were going to show up because of the scale that we had. Because we were not going to generate cached pages. We were going to generate dynamic pages for every page view because we needed to do this system lookup stuff and whatnot. And so we were a little worried that Django or some other framework wouldn't keep up to the load, and then we'd have to fix the framework. And we didn't know the framework as well as we knew TurboGears. It turned out that TurboGears handled the load without any, none of our problems were Python web framework problems. They were all, we were not very smart, and we made huge project record problems. So Django probably would have been fine, but also Django, the advantages of Django, like Django OpenID and Django Auth and Django admin and all of the things that make Django more valuable for rapid prototyping and for getting things done, wouldn't have applied to us at all because we weren't using the Django ORM. So we would have had none of the real advantages of Django, and we would have had all of the disadvantages of Django in terms of, in my opinion, the template language, which makes me want to hit myself really hard. Other people have a different opinion about that. They think that the constraints that it provides are good, but I think you should be able to put presentation logic in the template because that's the presentation layer. And we all agreed that that's what we thought. So we have developers who do front-end work, not designers who do front-end work. So for us, keeping Python out of the front end was not a goal. So we used Jinja again. And Jinja 2 now has been very useful to us. It's fast. It's much faster than Django template language, much faster than the Python default, which was Genshi, or Genshi. So we were able to make those sort of switches in TurboGears really easily and not as easily in Django. So that's why we made the switch, and it turned out really well for us. We got exactly what we needed.
Have you made an assessment in terms of effort and time and whatever of what it will take to port TurboGears over to Pyramid?
It's a very different subject. TurboGears, we're going to work with the Pylons and Pyramid folks. We're part of the overall Pylons project. Whether we actually rewrite TurboGears as such on top of Pyramid is still an open question. Pylons 1.0 is still supported. We can take over Pylons 1.0 support. We're part of the same project. It all works. So we may or may not jump on top of Pyramid. We certainly are going to continue to work with them to build new tools and tools that work for both us and Pyramid. Mike Orr's recent SQL Alchemy helper thing is something that I think we're going to incorporate. I hope that we're going to incorporate into TurboGears, and then it'll be incorporated into Pyramid, and it'll make moving back and forth between those much easier. And my hope and goal is that as time goes on, in a not backwards incompatible way, we can move together to a place where we can write shared components like an admin thing, like those sorts of site components that we can share across TurboGears and straight Pyramid. And then if there's a new full stack layer on top of Pyramid, that TurboGears and that will be sharing a lot. But our goal for right now is TurboGears should stay compatible with TurboGears. That's higher than moving on top of Pyramid, because we do not want to screw all of our users.
Hi. My question is a bit off topic. The sourceforge seems seemed always a bit old dinosaur to me. The popularity, the impact of popularity of GitHub push you do massive change to sourceforge.
I think Google Code was the warning shot across the bow for SourceForge, where they realized that if they don't do something, they'll become irrelevant. They didn't have subversion support. Like, they decided that they were going to get better, and then it took them a while to figure out how to get better. And really, like, they had decided that they were going to try to compete with Google Code and GitHub and those sorts of people when I started. They were just struggling to be able to do it. And now they're not, I think, as much struggling to figure out how to do it because they have Python. They have a talented developer team that knows what they're doing and cares. And they had that before. They just didn't have Python and all of the tools that it provides. They didn't have a modern framework. And they had management difficulties. There was a lot of chasing after the thing of the week. So you'd start a project and then never quite finish. Phosphorus would be an example. We spent 2 months on that and then we threw it away. Like, we took it down. It doesn't even exist anymore. But yeah, we are, we want to be relevant in the open source hosting space. We are, in terms of downloads. We have way more, we have 500, this quarter I think we will have 500 million downloads from SourceForge, which is a big number, and it is a much bigger number than GitHub. Like, couple of order of magnitudes, if not several orders of magnitude. So we do know we need to make big changes, and we are doing it. On that other hand, like, I'm also of the opinion that GitHub is a good thing, and there should be diversity in the open source project hosting ecosystem, and I'm happy for them to exist, and I think it's better for the open source world to have multiple options. I just think SourceForge has to be a relevant one of those options.
Was there a question over there or no? Okay, nobody else. Thank you very much, Mark.